So we are doing our project on endothermic versus exothermic reactions. Before we get into those, we're just going to give a little background information on phase changes. So there are three different states of matter: solid, liquid, and gas. And between the three, there are phase changes that occur. So when going from a solid to a liquid, we call this melting. And when we go from a liquid to a gas, we call this evaporation. And when we go from a solid straight to a gas and skipping over liquid, we call this deposition. And going the opposite way, when we go from a gas to a liquid, we call this evaporation. And from a liquid to a solid, we call that freezing. And going straight from a gas to a solid with skipping over the liquid, we call that sublimation.
So here we are showing endothermic reactions. So endothermic reactions are when you are adding heat to these phase changes. So it's anything going from left to right. So if you're taking a solid and converting it to a liquid, you are melting. So to do that, you need to add heat. Same with going from a liquid to a gas, that is evaporation. You need to add heat in order to do that. Same with deposition, which is going from a solid to a gas. So an example of adding heat to a reaction going from solid to liquid, say you have an ice cube and you put it out in the sun. In order for it to melt, you need the sun. So that's going from a solid to a liquid. If you didn't have the heat and it was still cold, the ice cube wouldn't melt because it is requiring that endothermic reaction.
And looking at exothermic reactions, heat needs to be given off. So that's anything in this diagram that is going from right to left. So going from a gas to a liquid, which is condensation, that's exothermic, as well as going from a liquid to a solid, which is freezing. And an example would be in the winter, if you have any like puddles on the ground and overnight it gets colder, so heat from the day is being taken away, then it's going to freeze and become a solid piece of ice. And looking to see if heat is either a reactant or a product, you have to know if your reaction is endothermic or exothermic. So if heat is a reactant, then the equation is calling for heat to be added. So this happens with endothermic reactions. Whereas when heat is a product, the equation calls for heat to be given off, which is in an exothermic reaction.
So here we have evaporation, which is one of the phase changes. So that is when you are going from a liquid to a gas, as we've shown above in the chart. So you're starting off with a liquid of water, H2O, and you're adding heat to that reaction, and you're ending up with H2O as a gas. So because that heat is being added to the equation, it is a reactant. So if heat is a reactant, the reaction is considered endothermic because the heat is required for that reaction to occur.
And another example would be freezing. So that's when you have H2O as a liquid and it changes into H2O as a solid. So the heat in this case is being lost. So heat is a product and the reaction is exothermic.
So here we have two equations that we'll talk through to help you decide if it is exothermic or endothermic. So in the first equation, you have two gases being added together. You have 2H2 plus O2. These are both gases, and it is being converted into 2H2O, which is a liquid, and you're also adding in the 135 kcals. So the 135 kcals is the product, so that's what's being it's being released through the chemical reaction. So because it is a product, it is exothermic. So you're breaking down the bonds of the 2H2 plus the O2 to form the bonds 2H2 2H2O. In the second one, you have N2, which is a gas, plus O2, which is also a gas, and you're adding in the 45 kcals. And you are converting that into 2NO, which is a gas. So because energy is required in this equation to go to the 2NO, it is a reactant. So as we said in the previous slide, that when they are reactants, when the heat is a reactant, it is endothermic.
And going off of what Maddie was saying about bonds, energy is required to break bonds, which we see in endothermic reactions. And when energy is given off, we will see that in exothermic reactions. So this chart below is just another way to show you exothermic reactions. So at the start of the reaction, you're going to have your reactants, and then when energy is given off, you're going to end up with your products. And that's what makes it exothermic.
So here's the other chart for endothermic reactions. At the bottom, you have time at the bottom left. So as time goes on, you are beginning with reactants and the heat is being absorbed. So you are adding heat. And so the product at the end, energy is absorbed and the reactants are converted to products. And that is the end of our presentation on endothermic versus exothermic reactions.